which is partial products. So over on the right, I'm going to set this up as a partial products problem. Thinking about the fact that I'm just going to rewrite, we're trying to find 49 times 57. That's what we're really trying to accomplish. In a partial products problem, we want to take those numbers and break them up in the same way that I did in the area model. Instead of just saying 49, I want to say 40 plus 9. And instead of saying 57, I want to say 50 plus 7. The reason we want to do this is because we want to help students really connect with the place value significance of each of the numbers here. The 4 is not just a 4, it's a 40. The 5 over here is not just a 5, it's a 50. The reason that in the traditional method we have to add zeros as placeholders and we have to carry numbers is because we're treating all the digits as if they're ones places. And they're not. Some of them are ones, like the 9 in 49 is a ones place. The 4 is a 40. It's a tens digit. So that is an important differentiator between the partial products method and the traditional method, even though the rest of it is going to progress very similarly. So let's come back over to partial products. 40 plus 9, 50 plus 7. We want to multiply them. The first thing that we do is we start with the ones digit, just like we would in a traditional problem, the 7. And we want to multiply it 7 times 9 and 7 times 40. If you are a math savvy parent already, this may remind you of the concept of the distributive property. The fact that I am distributing 7 to 9 and 40, the numbers that are up here in the top row. So 7 times 9 is 63. 7 times 40 is 280. Notice I didn't have to carry any numbers. Then we moved to the 50. We're going to distribute, in a sense, the 50 times 9, 50 times 40. So 50 times 9 is 450. And then 50 times 40 is 2,000. Once again, these numbers should look very familiar to you. In fact, they're exactly the same numbers that I had over here in the box method. They're flipped around just because of the way that I've written them, but exactly the same numbers. And those numbers are the same as the numbers that we got up in the traditional method. So when we sum them, we will get the same answer, 2,793. So take a second to look at these three methods. We have the traditional method. I'm just going to put a T over here for traditional. We have the box or the area model method. Box or area method. And then we have what we call the partial products method over here on the right. All calculating the same operation on the same numbers, but using different levels of explanation, in a sense, to a student, using different strategies so that I can answer their questions when they ask, why does this work? If you want to teach your child the traditional method with the carrying of numbers and the insert the zero as a place value, all that, if you want to teach them that method, or if a teacher is going to teach them that method, which is not a problem, all of these methods work, they all get us the correct answer, it's important to teach in the correct order. You don't want to teach the abstract method, the one that they can't really connect to, that they can't really find a hook to say, why does this work, so that they'll remember it. You don't want to start with that method. You want to end with that method. So you want to start by talking about area. Then use what we understand about area to talk about the area model. Then you want to use what we learned in the area model to talk about partial products, and from there students are ready to connect with the more traditional algorithm. So, most important thing to hear here is order matters. It really, really does matter what order you teach things in.